2020, Pure Unit 2, Paper 1. Which of the following is a sketch of the locus of the point represented by the complex number z given by z? This is a repeat question, but as requested in previous years, we're going to go through the working for it, right? So modulus of z take away open bracket 0 plus 5i is equal to 3. The center is going to be 0, 5, and the radius is going to be 3. So the answer is going to be B. Number 2, the roots of the equation are plus or minus I. We know this already. This is a repeat question. Number 3, this is also, this is integration by recognition. The numerator is f dash x over f of x. When I integrate this, I'm going to get ln modulus f of x. Don't forget the half in the front. So a half modulus tan x plus c. This as well is a repeat, but just make sure it's the correct complex number we're looking at, right? They could be a little tricky and put instead of 1 over 1 minus I, they could put 1 over 1 plus I. So let's go ahead and rationalize this. 1 over 1 minus I multiplied by 1 plus I over 1 plus I. The denominator is going to be 1 squared minus I squared, which is 1 squared minus minus 1, which is 1 plus 1, which is 2. So a half plus a half I. A half plus a half I is going to give me A as the answer. Number 5, the value of this so just use De Moivre's theorem, bring the 4 in front. Cosine of pi is minus 1. I sine of pi is 0, so minus 1 is the answer. The gradient of the tangent to the curve at 2, 1 is, so let me go ahead and differentiate this, right? So we go ahead to use the product rule. So 3x squared, take away open bracket, and I'll go ahead and use the product rule. V by du dx plus u by dv dx, which is y dy dx, 1 dy dx, sorry, plus 2y dy dx is equal to 0. So when x is 2, y is 1. 3 into 2 squared, take away 2 into 1, take away 2 into 2 dy dx plus 2 into 1 dy dx. 4 3s are 12. 12 take away 2 is 10. Take away 4 dy dx minus 4 plus 2 is minus 2 dy dx. Move the 10 across, I get minus 10. Divide by minus 2, and I'm going to get 5 to be my answer. So when I differentiate in cosine function, it's going to be minus the derivative of the angle. So it's minus a half over the square root of 1 minus x over 2 all squared. We had to do some work. I take in the denominator. 1 minus x on 2 all squared is 1 minus x squared over 4. The square root of all of that, which is going to be 4 minus x squared all over 4 is the square root of all of that, which is going to be the square root of 4 minus x squared over 2. So it's going to be minus a half divided by this, which is going to be minus a half multiplied by 2 over root 4 minus x squared. That and that cancel. I get in minus 1 over 4 minus x squared. The answer is A. If dy dx is 2xy, the value of the second derivative, we did this question just now. I think the answer was 16. Was it 16? I can't remember, so let's do it over. So it was 12, right? So it's going to be v by du dx plus u by dv dx. And dy dx is going to be 2xy. So it's going to be 2y plus 2x squared y. I can make it fancy, factorize 2y from each of these things and probably get to be working out a little bit easier. 1 plus x squared. So I'll get 2 into 2 multiplied by 1 plus 1 squared. So 2 2s are 4 multiplied by... Nah, make a mistake somewhere. Alright, so I'm going to factorize now. I'm going to plug it in right here. 2y plus 2 into 1 squared multiplied by 2. 2 2s are 4. Phi du dx here. 4 plus 2 2s are 4. Yeah, again 8. Make a mistake. I did make a mistake. 2 by 2 is 4. Right? So this 2 by this 2 is 4. So again 4x squared y. So there's going to be 4 here. 4 2s are 8. 8 plus 4 is 12. Alright, so don't be in a rush like I in a rush. I know sometimes when we see repeat questions, we just get antsy. So just take your time. I know we're going to have more than enough time, right? Okay. Now, this is what I'm going to advise you guys for questions that has modeling in them. Let's just cross our fingers, hope and pray that the modeling questions that come are repeat questions. It have more than one different modeling question that can come for the paper ones. Let me just hope one of them repeats. For this one, we can figure out what it is. All right. So the number of bacteria present in a culture is modeled by the equation y is equal to y naught e to the kt, where k is greater than 0. Y is the population of the T hours, and y naught is the initial population. The rate of growth c. So the rate of growth is going to be a rate of change, which is dy dt. So them saying dy dt is represented by c. So let me go ahead and differentiate to get dy dt. Dy dt is equal to k multiplied by y naught e to the kt. And they say when t is 5, so I just rubbing off the t and I put in a 5. So c is equal to k y naught e to the 5k. K y naught e to the 5k. Y naught is the initial population. The integral of 1 over 9x squared, again, this is tan territory. If you remember anything from the previous year or the year before, it's 1 plus 3x all squared. I had to differentiate the function to get a 3 on top. I had to slap the third on the outside. It's going to be a third tan inverse of 3x. 1/3 tan inverse of 3x plus c. Alright, number 11. Given that cos 2x is equal to 1 minus 2 sine squared x, then the integral between pi and 4 of sine, or pi and 0 of sine squared x on 4. This is actually a unit 1 question. It is a unit 1 question. Alright, so all I'm going to do is I'm going to let x be x on 4. That's all I'm going to do in the identity. So I'm going to get cosine of 2 into x on 4 is equal to 1 minus 2 sine squared into x on 4. I'll make this the subject of the formula. I'm going to get move the sine, move the cosine. So I'll get in sine squared of x on 4 is equal to a half. Move the cosine, I'll get minus cosine x on 2. So when I integrate in, I'll have to integrate this side, and that side is the same thing. So when I integrate a half, I will continue the working on it. I will continue it up here and fit it up, yes? I'm going to get a half x When I integrate cosine, I'm getting back sine. So I'll get back minus sine x on 2. And remember, I am integrating, so I must divide by the derivative of the angle. If I'm dividing by 1/2, I am multiplying by 2. So I will do that multiplication in the next line. So 1/2 x minus 2 sine of x on 2. I know when I'm plugging the lower limit, I get in 0 throughout, so I'm just going to plug in the upper limit. I'm going to get 1/2 pi, take away. Sine of pi on 2 is 1. So 1/2 pi take away 2. So pi on 2 take away 2. We don't have that. Sine of, 2 sine of x on 2. Oh. This have to divide by 2 as well. My bad. So this is going to be divided by 2. And I'm multiplying this by the, I'm dividing by the half. So this could cancel and I get 1. So I would get just sine of pi on 2, which is 1. Right? My mistake. So 1/2 pi on 2 minus 1, the answer is C. Right? So when I divided both sides over here, when I divided both sides by 2 to get rid of the 2 in front of the sine, I forgot to divide the cosine of x on 2 divided by 2. Right? Slight mistake, but it could cost you. dy dx is y squared minus 1. The solution of the differential equation can be expressed as, so let me just check and see the options that we have here, right? In the options we have, well, they separate the y squared minus 1 into partial fractions. All right? So I just go and focus on what the partial fraction for y squared minus 1 is. We're going to get a over y minus 1 plus b over y plus 1 is equal to 1 over y squared minus 1. Difference at LCM down the place, y plus 1 by a plus y minus 1 by b over y minus 1 into y plus 1 is equal to 1. Let me go ahead and set y to be 1 first. So I'll get 2a is equal to 1 and a is 1/2. So the number above y minus 1 going to be 1/2, or I will have 1 over 2 multiplied by y minus 1. So 1 over 2 multiplied by y minus 1, the only option that given me that is D. If you want, you could continue to work out what B is just to make sure. Let me set y to be minus 1. I'm going to get minus 2b is equal to 1, and b is minus 1/2. So we're going to get minus 1 over 2 into y plus 1, which is this here, minus 1 into over 2 into y plus 1. So D is indeed the answer. So this one is straightforward repeat question. You could see it. It'll have no beating around the bush. B is the answer. The principal value of the argument of the complex number. Again, it's another repeat question. Give me a second. The principal value of the argument of the complex number minus 2 plus 2i is, so let me get alpha. Alpha is going to be tan inverse of 1, which is pi on 4. This complex number existing in the fourth quadrant, so the principal value of the argument is going to be minus pi on 4. The answer for this is B. A lie. Minus 2 plus, that is in quadrant 2. So it's going to be pi minus pi on 4, which is going to be 3 pi on 4. My bad. Alright, so I know number 15 would have been a little bit of controversial question because the variables we have is s and t in the question, and in our answers we have k, x and y. Alright, so it's okay, I guess, once we maintain the same transition from S to Y and T to X, we should be fine, right? In a chemical reaction, the amount of a substance S present at time T is modeled by the differential equation ds dt is equal to this, where A, B, and K are positive constants and A is greater than B. Given that S is equal to 0, when T is equal to 0, then an expression for S in terms of T may be found by solving the equation. So basically, they want us to solve this differential equation here, but instead of using S and T, we're using Y and X. All right? So if I bring in all the S's next to the ds, it'll be ds over A minus S into B minus S is equal to K dt. When I integrate both sides, all of the limits are going to be, well, it can't be these limits here, right? Because S is greater than 0, they say. They say A, B, and K are positive constants, and A is greater than B. They didn't say nothing with the limits. Well, they say S is 0 when T is 0. Okay, so I'm going to make sure that all my... No, it might make a difference, you know. Let me go ahead and see, right? So when I integrate both sides, I'm going to get the integral of ds over, or 1 over A minus S into B minus S is equal to the integral of K dt. This is the only one that really resonating with that particular answer. All the others are not. So I'm going to say B is the answer. I'm not even watching the limits. This is another repeat question. The first term is going to be 2n to the power 0, which is 1. The difference is going to be 2n. We want to know what the sum to infinity is. So this is A and this is R. A over 1 minus R. 1 over 1 minus 2n. The answer is B. Next, the value of this is another sum to infinity question. In this case, 1 minus 1 is 0, so A is going to be 2, and R is going to be a half divided by 2 is a quarter. A over 1 minus R is 2 over 1 minus a quarter. 2 over 3 quarter, which is 8 over 3. Yes, I know it's a repeat. I'm still doing over the question. The binomial NC2 is equivalent to, just make sure the numerator n is greater than the number below it, right? So in this case, n is greater than n minus 2, so we in the game D. Over here, n minus 2 is indeed less than n, and the top is less than the bottom. So indeed, B is the answer. 93rd term in the power series expansion, that is to the power minus a half, where the modulus of x is less than 1. So when we expand, we're going to get 1 plus, is it n f of x? It's n f of x minus a half by x plus the third term, which is this term, minus a half into minus a half minus 1, n into n minus 1 into f of x squared, which is going to be x squared over 2 factorial. Let me work out what this is. Get my calculator. Nice, we could see it there. Minus a half by minus 1 half multiplied by, voila. Now I'll put that whole thing in brackets, right? So we get in oh shucks, I want to bracket it off. Brackets minus 1 half 1 over 2, close brackets, multiplied by minus a half minus 1 minus 1 over 2 take away 1, close brackets, equals, divided by 2 factorial is just 2. Again, 3/8 x squared. So 19 is D. The sum of the first n terms of a series is 1 minus a quarter to the n. The value of the second term is let's see. So if the sum of the first n terms, we could calculate what the first term is by calculating the sum of the first term. So let me do that. Let me just try a thing here, right? So S1 is the sum of the first term. S1 is T1, and this is equal to when n is 1. So 1 take away a quarter, which is 3/4. S2 is T1 plus T2, and that is going to be 1 take away a quarter squared, which is 1 take away 1/16, which is 15/16. If I take away S2 from S1, I'm going to get T2. So 15/16 take away 3/4, 15/16 take away 3/4 equals 3/16. So A is the answer for number 20. Alright, so let A sub n and S sub n denote respectively the value of the nth term and the nth partial sum of a series. The value of n sub S sub n plus 2 take away S sub n. So we do this just now. The sum of all the terms, all the n plus 2 terms of the first n plus 2 terms, if you may, is A1 plus A2 plus A3 all the way up to AN plus AN plus 1 plus AN plus 2. And S sub n is going to be A1 plus A2, A1 plus A2 all the way up to A sub n. So when I take them away, all the terms up to A sub n goes away, and I remain with A n plus 1 plus A n plus 2. C is the answer. Alright, so given that un represents the nth term of a sequence, which of the following converges? We know based on our history with this question, it has repeated twice in a row. If the limit as n tends to infinity is equal to a constant L, then it converges. A is the only one that will approach infinity and give us a constant L. Alright, so this is another repeat question. So we had, no we didn't. No, we didn't have one to help us here, so we had to go through this one all over again by itself, right? So let me see what the method of differences is for this one, right? So when I is 1, I'll get 1 take away a half, then I'll get a half take away a third, then I'll get a third take away a quarter. So the first term survives, so the last term will also survive, right? So the last term will come when I is n, take away 1 over n plus 1. So 1 take away 1 over n plus 1. This becomes n over n plus 1, n plus 1 minus 1, yep. And as n tends to infinity, I'll divide this by n, I'll divide this by n, and I'll divide this by n. So we get in 1 on top, 1 below, and 1 over n goes to 0 as n tends to infinity. So the answer for 23 is 1. The coefficient of x to the power 4 in the Taylor series expansion for f of x is equal to cos x about x is equal to 0. This is another repeat question. If I remember correctly, I think the answer for this would have been 1 over 24. So just to save us a little bit of time, it come like I'm still doing the question, but I will go back in the previous year, 2019. I believe it was 2019. And let's see, what number is this? That was number 20 something, and so number. Oh, all I'm doing is I just go for look at my working, right? Okay, so apparently it didn't repeat in the 2019 paper. What about the 2018 paper? Did Homeboy repeat? So 2018, zoom out a little bit, zoom out again. 20 something. Right, just it will save us some time, right? Yeah, look at here. All right. The coefficient of x to the power 4 in the Taylor series expansion of f of x is equal to cos x about x is equal to 0. Yep, 1 over 24. We will be looking at let me go to the next set of solutions I have for this, which is the first set here. Nice. Alright, so we're looking at all the derivatives up to the fourth derivative and plugging that into our Taylor series expansion. It's that simple as that. Alright, 1 over 24 would have been the answer for that one. Alright, the equation x cubed minus x minus 3. Just double check and make sure that how they give you the function that has the root between 1 and 2. I believe it was 1.67. 1 minus 1 and minus 3. Oops. 1, 0 minus 1 and minus 3. 1.67. So it's between 1 and 2. Which of the following statements are true? You realize the kind of mixing up the repeats for this one here. By the method of process of elimination, A cannot be correct, B cannot be correct. C has to be correct because when I split up the summation, I'll get the summation of 2 as r goes from 1 to n. That's going to give me 2n. And I'm going to get the summation of r squared as r goes from 1 to n. Given that the coefficient of the term in b cubed in the binomial expansion is 40, then A is equal to... So if the coefficient of b cubed is equal to 40, then I could safely say that if I do this, right, NCR A to the n minus r, b to the r, and I'm looking for the coefficient of b cubed, I can safely say that r is 3. Right, because b is b at the end of the day in this particular expansion. So if r is 3, I'm going to get 5c3 a to the 5 minus 3 b cubed. I'm not concerned with the b cubed. I'm concerned with this here. What is 5c3? Going on my calculator. 5c3 is 10. So I'm going to get 10a squared is equal to 40. A squared is 4. And a is plus or minus 2. In this case, a has to be 2. Right, next, the sum of the infinite geometric series. This is a repeat question. A is 180 and r was a third, negative a third. So I get 180 divided by 1 minus a third. And I got 135 to be my answer for this. A suitable Newton-Raphson iteration for the equation. Alright, so we know that for Newton-Raphson, it's going to be x take away. I put in f of x over f dash x. Alright, after I do this, I just replace an x with x sub n. So it's x take away f of x, which is going to be e to the 2x plus 4x minus 5 over 2e to the 2x plus 4 cross multiply 2x e to the 2x plus 4x take away e to the 2x take away 4x take away 5 plus 5 actually. So the 4x and the 4x goes. It could be over 2e to the 2x plus 4. All of them are 2e to the 2x plus 4 on the denominators. All the answers, all of the options are that. I am just looking to see what the numerator is going to be. So I can factorize out e to the 2x. So I'm going to get e to the 2x into 2x minus 1 plus 5 on top. Just replace x with x sub n. So 2x sub n into, e to the 2x sub n into, nice, 2x sub n minus 1, right? And we have a plus 5, so the answer is D. The coefficient of x to the power 11 in the expansion of this is, so if we're looking at the coefficient of x to the power 11, r is going to be 11. So I'm going to get 12c11 into, afterwards I go multiply by 2. Alright? So 12c11 into a to the power of 12 minus 11, x to the power of 11. Where's 12c11? I think that is like 2. Let me do this. And let me do this. Nice. So 12c11 like 12. So I'm going to get 12a x to the power 11. We want the coefficient of x to the power 11. Now don't forget that 2 on the outside there. 12a is the coefficient of a plus x to the 12. When I multiply that by 2, I'm going to get 24. A is my coefficient. If M is that, the first row of the cofactor matrix of M is, this is a repeat question. So the first row of the cofactor matrix is going to be 24 take away 5 is 19. So 19 is going to be my first entry, and it's going to be a positive 19. The only one that has that is option C. In how many ways can the letters P, Q, R, S, T, U be arranged so that T and U are always together? If T and U are always together, then I have P, Q, R, S, T, U, which is 5. I have to arrange 5 things, which is going to be 5 factorial, and T and U can interchange places, so it's going to be 5 factorial multiplied by U. By 2, sorry. Alright, so 2 cards are drawn from a pack numbered. So this is the same question that we would have had previously, and 3 tenths. I got 3 14ths to be the correct answer. Maybe I checked it wrong, but yeah, let me just revisit the previous paper. The answer is 3 tenths. I distinctly remember the answer being 3 out of 14. I would like to double check that. So if we do count the primes, I know we have, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yeah, and nothing repeated. The product was a probability that the product of the two numbers is prime. 5 3s are 15, 5 4s are 20, 25, yeah. It's 3 out of 14, not 3 out of 10. Okay. Alright, so the answer that they was looking for in this particular scenario would have been 325s. That's my assumption. This is a repeat question with the equal, real, and equal roots. When x is 0 and y is 0, our B coefficient, turn out to be 0. So we would have gotten ax e to the minus 3x. But a and b are just constants. They are just placeholders. Again, 35 is a repeat question. We did this one 2 years in a row. So, I mean, it's a no-brainer. E to the integral of 2 over x, which is e to the ln x squared, which is equal to x squared. 2 coins and a die with faces numbered 1 to 6 are thrown together. Assuming that the die and the coins are fair, the probability of obtaining 2 heads and a number less than 4 is, so that was 3 three scenarios where we got the heads and the number less than 4. We will get a heads with a 1, a heads with a 2, and a head with a 3. And the total number of possible outcomes would have been 6, and then 4 for the 2 coins, so 6 4s are 24. So 3 out of 24 is 1 out of 8. The cofactor of the element 3, this element 3 here will have a negative in front of it, 1405, negative 1405. The answer is B. The solution, the general solution of the differential equation is, this is the one where we assigned the constant to be ln of k. So when I rearrange, I'll get dy over y is equal to dx over x. So ln y is ln x, and I put in ln k as the constant, which is no problem. I'll get ln y is ln kx, which is y is equal to kx will be the answer. Answer is B. The following refers to the equation of the 3 planes. So we did this one just now. We're checking to see if they are parallel. First one and second one not parallel, because in order to get 2x, I must multiply equation 1 by equation 2 by 2. If they were parallel, this will be 2y, this will be 2z, and this will be 2. So these two are not parallel. First and the last one not parallel, and these two are not parallel as well. So they are not parallel. So the planes are not parallel. Because they are not parallel, we will have a unique solution. So 2 and 3 is going to be my answers. Alright? And the equations are inconsistent? No, they are consistent. From the letters A, B, C, D, and E, the number of 3-letter words that can be made if no letter is repeated is going to be 5, pick 3, which is going to be 60. Number 42. I'm sorry, number 41. The number of possible values of x which satisfies the system. So watch this one here, right? I know these two here are not parallel. But let's take a look at equation 1 and equation 3, if we were to label them, this and this. To go from -5 to -15, I have to multiply by 3. Let me see if it happens for all of the coefficients. 3 2s are 6. 3 3s are 9. 3 2s are 6. 5 3s are 15. So we did multiply by 3. So we have a pair of parallel lines. So we have no solutions. 42 is a repeat question. This one is a no-brainer. ABC is P right here. P by D. Alright, so 43 is also another repeat question. If Chad, Matthew, Josh, Paul, and Tiffany, 5 people, are traveling in a 5-seater car, 3 persons in the back, 2 persons in front. Each occupies a seat. The number of different ways they can sit in the car if Tiffany sit down in the back, Josh driving. So Josh driving, case closed. He done sit down already. So we have 4 people to sit down. Tiffany sit down in the back. So we have 3 people to sit down. The number of ways I can seat those 3 people, the number of different ways I can seat them is going to be 3 factorial. And then Tiffany can sit down in one of the 3 seats in the back. So it's 3 factorial by 3 plus 3 factorial plus 3 factorial, or just 3 factorial by 3. 3 2s are 6. 6 3s are 18. The general solution for the differential equation, our 2 solutions for this would have been 0 and positive 3. So it's going to be C1 e to the 0x plus C2 e to the 3x. This is just going to give me C1. So a constant plus a constant by e to the 3x. The answer for number 44 is C. And finally, number 45. Given that y is pi on 4 and x is equal to a half, the particular solution of, so let me rearrange, we're going to get dy over cos squared y. This is dy sec squared y dy, which is going to give me tan y, is equal to the integral of 2x dx. So tan y is equal to x squared plus c. When y is pi on 4, tan of pi on 4 is 1. When x is equal to a half, x squared is a quarter. 1 minus a quarter is 3/4. So c is equal to 3/4. So A will be the only answer for this one here. And that's it for 2020.